In section 2.1, we're going to talk about points, lines, and planes. Just to get into some basic definitions here, a point clearly looks something like that, and it indicates a location and it has no size technically. We would call a point just by the letter that's with it. Moving on to a line is a straight path, it has no thickness, and it contains infinitely many points. Different ways that we could name a line could be 2 points that are on it, such as AB. Since a line's symmetrical, we could also go the other way and call this line BA. And sometimes you'll see in certain diagrams, they'll give like a cursive lowercase letter with it. So I also, in this case, could call this line L, because I see that cursive L with it. Finally, a plane is a flat surface and it also has no thickness, and that contains infinitely many lines. You could name a plane by doing any 3 non-collinear points. So I could call this plane, well, I first could call it plane P, because sometimes you also get a letter with it. I could call this plane ABC, BCA, again, any 3 non-collinear points. And you might be thinking, what does non-collinear mean? Which is what we're going to talk about next. So points that lie on the same line are called collinear. So if I have a line with point X on it, Y would be collinear, Z would be collinear. Point Q, we could see we couldn't draw a straight path through all those points, so Q would not be collinear or non-collinear with those. Points that lie on the same plane are coplanar. So if we have a plane with point A, B and C would be coplanar. Point D would be non-coplanar. Finally, again, just getting some basic definitions out of the way here, we have a segment, ray, and opposite rays. A line segment would look something like this. It's defined by having 2 definitive endpoints. Again, since this is symmetrical, we could call this segment AB or segment BA. A ray, on the other hand, would look something like this. An array only has one endpoint, and the other way we're going technically for forever, in the opposite direction. We could call this ray AB. Since this is not symmetrical, we can't go the other way here. So I could not call this ray BA. What's important about when I'm naming a ray is that when I see ray AB, that tells me that point A is the endpoint, and I'm going in the direction where I'm going towards B. Finally, opposite rays would be 2 rays with a shared endpoint. So in this diagram, ray AB is opposite of ray AC. Finally, last couple definitions here. Lines that are on the same plane that never intersect are called parallel lines. So let's say we have this imaginary plane here. These 2 lines would be parallel. They never intersect. That's what's important to know about parallel lines. Finally, lines that are non-coplanar that don't intersect or skew. These are a little bit harder to visualize. Let's say we have our imaginary plane here, and we have a line going this way. What if I have a line going this way? We can see here, just by like the 3D image there, these aren't going to intersect, but they don't look like they're parallel. That would be called skew lines.